All right, so back to 3.4, dealing with slope. Let's just go right into our first example problem. And what they're doing with beginning of 3.4 is they're giving you 2 points. In this example, we have 4, 2 and 3, -1. What you're going to do with those 2 points is they want you to find the slope. And so let's talk a little bit about what is slope. And we're going to go into some decent slides in the PowerPoint. So again, when you're giving 2 points, okay, and once you have 2 points, it's very easy to find the slope of the line. What slope is rise over run, which means the change in y. So when you're talking about rise, you're talking about going up or down. So change in y is the direction that you're moving up or down, over run, which is a change in run, we're talking about left and right. So think of rise as going up and down, and run is going left and right. So you change in y over change in x. And then you'll see here it says the 2 x values can't be equal, and we'll talk about what happens if those 2 x values are equal and how that affects the slope. So when you are again given 2 points and they want you to graph that line, you take that first point and you write that as xy 1 1 and the second point as x2 y2. And I'm going to go back into our problem because this is the most important part of graphing or identifying your slope. So again, you have 2 ordered pairs. In other words, you have 2 x and y points. So that was the first thing that I would do, is write xy, xy. And again, you have the first point and you have your second point. So what you do is you write, this is x1 and this is y1, and this is x2, this is y2. And each of these apply to, so x1 would be 4, y1 would be 2, x2 would be 3, y2 would be -1. So that is important, that you got to be careful not to write this as x1, y2, and this is x1, y2. It's 1 and 1, and then you go 2 and 2 on the second point. And so each of these go into what we call the slope formula. And your slope formula is y2 minus y1 over x2 minus x1. All right, so we're going to plug in these points. Y2 is -1. Now remember, the formula is y2 minus. So you always want to put a minus before you even look at what the next point is. Y1 over here is 2. Then we're looking for x2. x2 is equal to 3. And again, it's minus. And x1 is equal to 4. So hopefully by now we're pretty good with subtracting and adding integers. If we're not, use a calculator. We got to make sure we don't get these wrong. A -1 take away 2 would give me a -3. 3 take away 4 would give me a -1. And what's the rule? When I have a negative over a negative, they both turn into a positive. So you could enter that answer as 3 over 1, or really, what is 3 over 1 equal to? It's just equal to 3. Let's go back into our problem. So what is the slope of this line? The slope is equal to 3. And if you write it as 3 over 1, that would be fine as well. All right, let's go to, and that's basically how you're going to answer the first few problems. If they give you 2 points, that's what you're going to do. And let's talk about what happens when I get zeros on one of my slopes. So we have these points here. 6, and 9, 6. All right, so again, first step, we're going to label, give these values, x, y, x, y, and again, it's first point, so we go 1, 1, 2, 2. Sorry, that 2 is a little weird. But I can't stress how important it is that you properly label these points. I've seen so many mistakes that people write, this is 2, 2, and 1, or different things like that. Remember, it's 1, 1, 2, 2. X, Y, X, Y, and then we go first point, they're both 1s. Second point, they're both 2s. Again, we're using the slope formula, y2 minus y1, x2 minus x1. That is a great formula to memorize because that, like I said, is not going anywhere. You're going to deal with that formula into geometry, into algebra 2, college algebra. That's not going anywhere. So again, y2 would be, so we're going to have 6 take away y1, which would be 6 minus 6, over x2, which is 9, minus x1, which is 6. So you end up getting 0 over 3. We know 0 divided by 3 is just going to be 0. So what type of line are we talking about where we get a slope of 0? And let's spend some time talking about that, but let's go ahead and put our answer in first. So slope is 0. Let's look at our PowerPoint. All right, so we have this kind of gives an example of rise over run. Just different examples of finding the slope and graphing. Talks about a positive slope going as you move left to right. Again, you're looking left to right. If you're going up, that is a positive slope. Left to right going down, that is what we call a negative slope. I'm trying to get back to the, all right, here we go. So when we get a slope of 0, what that means is it is a horizontal line. Okay, so that means the key is you got 0 in your numerator. So 0 in the top part of the fraction, your slope is 0. If you get 0 in the bottom half of your fraction, okay, so again, it's a horizontal line. If you get 0 in the bottom part of your fraction, that is undefined. Remember, we cannot divide by 0. And what that means is that graph is a vertical line. So keep that in mind as we get to that next example. Which is number 5 here. All right, so let's look at, so it wants you to find the slope of the line x equals 1. We go back though. So let's look at this problem right here. This is more traditionally how you're going to see it. -10, -7, and then -10, comma, -10. And we are looking for the slope here. So first thing always, label our points, x, y, x, y. This is 1, 1. This is 2, 2. So our slope is -10, take away, whoops, write that in black. Y2 is -10, and we are subtracting y1, which is -7. And then this is kind of that first example. Remember, we're going to have these double negatives. When we have double negatives, they both turn into a plus. Okay, so this is actually going to be -3 on top. But let's do our bottom numbers, our x2 minus x1, which would be -10, take away a -10. So in other words, this is going to be -10 plus 10. So -10 plus 10, that's going to give me 0. So I want you to see the difference between these two. Here, my 0 is in my numerator. That's okay. That answer is just 0. Okay, and then what that is that's a horizontal line. All right. When we get 0 in the denominator here, our slope is actually undefined because we cannot divide by 0. And anytime we get an undefined slope, we're talking about a line that is vertical. And remember, vertical line is going to be x equals some number. A horizontal line is going to be y equals some number. So just know we have a vertical line where it says x equals something. That slope's undefined. We have a horizontal line where it's y equals some number. That slope would be 0. So know the two differences. Vertical line, our slope is undefined. A horizontal line, our slope is 0. I'm sorry if I haven't said it yet, but m is what we use for slope. All right, our next type of problem, let's look at this example here. So they are giving you these 2 points and it says find the slope of the line. There's a couple ways you can do that. You can just look at this and determine the rise and the run, okay? But one of the easier ways is if I can just find out what this point is and what this point is, I can use the slope formula. So let's look at this first point here. What is this point right here? Again, you start at your origin, you go to the left 1, which would be -1, and then I go up 2. So my first point would be -1, comma 2. Now let's figure out what this point is. Again, at the origin, I'm going to the right 1, so that'd be a +1, but then I'm going down. So the slope there would be, the x would be +1, but the y would be -1. All right. So again, I have these 2 points. If I have 2 points, I can find that slope. As long as I label it properly and apply the formula properly. It's x1, y1, x2, y2. Again, make sure you know the formula. y2 minus y1, x2 minus x1. It's y minus y over x minus x. y2 would be -1 minus, then I look over here at 2 over x1, which in this case is 1, minus a -1. -1 take away 2 would give me a -3. Now just be careful here, don't say this is 0, because it's 1 minus a -1. So it's actually 1 plus 1. So my slope there is going to be -3, comma 2. And again, what does that tell you? That means if I'm at this point and I go down 3, because it's -3, right? 1, 2, 3. And then my denominator is 2. That means run 2. So again, it's rise -2. So instead of going up, I'm going down because it's negative, down 3. Run 2, I'm moving over 2. So -3 over 2. So you can look at this maybe and determine that. If not, use the 2 points, come up with your slope, -3 over 2. And here we got it. All right, so let's talk about this line. We already said if it's x equals something, even if you just go back to the notes that I just showed you. Remember, x equals something, we know it's what kind of line? It is a vertical line. Okay, so in this problem, I think it was x equals 6 maybe, I don't recall, but it doesn't really matter what exactly x equals. We just know if it's x equals something, our slope is going to be undefined. So let's come back. Again, x equals 6. Let's find a similar question. It doesn't really matter. This is x equals 7. It's a vertical line. What's the slope going to be? Slope's going to be undefined. You got that. So we know that if it's x equals something is undefined, y equals something, y would be a horizontal line. What do we say if it's a horizontal line? A horizontal line has a slope of 0. And again, that's kind of what we were doing. Over here. Okay, horizontal line is going to be y equals some number. The horizontal line, our slope is going to be 0. All right. Let's go into some of our other problems. All right. So now what they're going to do is they are going to give you the equations of 2 lines. And I want to talk about the 2 different types of lines you're going to see in 3.4. Or really the two types of lines where it's relatively easy to find the slope. So our first type of line is y equals mx plus b. And this is called our slope intercept form. Biggest thing you're going to notice with this line is the y is going to be by itself. The y is by itself, followed by other values on the other side. The number in front of your x, okay? So the coefficient of the x, as long as it's in slope-intercept form, that is going to be your slope. So something in y-intercept form is probably the easiest way for you to find your slope. Okay, just look for the number in front of the x, and there you'll have your slope. The other type of problem they're going to give you on 3.4 looks like this. And this is what we call our standard form. This one requires a little bit more work, okay? But the easiest way to find the slope here is to take the value that's in front of the x, and you go -a, and then you divide it by b, the number that's in front of y. And we'll do various examples of this. But these are the 2 ways. If it's not in one of these 2 forms, then you want to do whatever you have to do to get it into one of these forms, whichever is easier. Sometimes it's easier to move the x and y's on one side. Sometimes it's easier to just isolate the y. But it has to be one of these 2 ways to find your slope. If it's in standard form, again, how do you find the slope? You take the number in front of the x, take the opposite of it, and divide it by the number in front of your y. All right, and so we'll do some examples of that and show you it's really kind of painless. Let's go into this problem here. Let's get a similar question. All right, so what form are we looking at here? Okay, we notice the y is by itself. So this is actually in what we call slope-intercept form. So how do I find the slope if it's in slope-intercept form? It's the number that's in front of the x. What's that value? That value there is just 3. check your answer, and you're good. So we come right into a number that's in what we call standard form. Let's look at that one a little bit more. I wonder if we can find a better question. All right, I like this one better. All right, let's go into our, all right, so we notice this is in what we call standard form, okay? So we need our A value and our B value to be able to determine that slope. So again, it is AX plus BY equals C. We don't concern ourselves with C at all as far as finding the slope, but I need to know what my A value is and I need to know what my B value is. So A is not that bad. We know A is the number in front of X. So in this problem, our A is 6. B, hopefully by now, we know that even though we don't see the number, it's there. That is a 1. So again, the formula, when it's in standard form, you just do negative A and you divide it by B. So if A is 6 and we're doing negative A, we're going to get a negative 6. We're going to divide it by 1. And what's that going to equal? Just negative 6. So the slope for this problem right here is negative 6. All right, let's get a similar question on this one. We got a different example here. This is number 10. 2x minus 3y equals 6. Oops. Sure. All right, so we're looking at this problem right here. We need our A and our B. Our A is going to be 2. Our B in this case is actually a negative 3. And it's in standard form, so we're using the standard form formula for slope. We're going to take negative A, in this case it's 2, so we're doing negative 2, divided by B, in this case is a negative 3. But when I have negative over a negative, we know that we need to make them both positive. So our slope on this problem right here would be positive 2 over 3. And we are good on that one. 11's a little bit different. So let's talk about our options on number 11. So we have X equals 8Y. So we are not, as this problem is, it is not in standard form. We're looking at number 11 here. It's not in standard AX plus B. It's not X and Y on both sides, or it's not really, the Y is not by itself. So we could either get the Y by itself by dividing 8 to both sides, or in this case, I'd probably just subtract that 8Y over here, get it into what we call standard form. So we're going to have 8X minus 8Y equals 0. So it looks like this. So I have my A and B. Right, I'm going to use slope M equals negative A over B. In this case, negative the 1, so negative 1 over B, which is negative 8. So I got a negative and a negative again. That becomes positive 1 over 8. All right, and I just kind of want to, if you chose the other route, in other words, what you could have done, and say, okay, I want to get that Y by itself. I'm just going to divide 8 to both sides. And it would look, I'm going to flip it around just so you can kind of see it. So this is what you get, okay? And really, this is the same thing because there is a 1 here, okay? And you see the 1 over 8 here and the 1 over 8 here. So that's where you kind of have a choice to do. You can make it, you either got to put this in standard form to find the slope, or you got to put this in slope intercept form. the slope-intercept, just that last number would be +0. Okay, but whatever you feel is easier, get it either in standard form and use the standard, the formula for finding the slope in standard form, or if you get it in slope-intercept form, we know slope-intercept form, the slope is the value in front of x. Okay, so this one looks a little bit different. You don't really see it originally, but you know this is 1/8 divided by x. Yep. This, check your answer, and go on. All right, and we'll do one more of these in standard form. Just some bigger numbers, but it's really not hard. So we got 55x minus 5y equals 1.9. The 1.9 might scare you, but we really could care less about that number. It doesn't apply as far as finding the slope. We do want to recognize that this is in standard form, which means I can use this equation to solve it. And just remember, you're doing the opposite of whatever a is. So in this case, a is positive 55. We're going to make it negative 55. And we're going to divide by b, which is negative 5. Well, negative 55 divided by 5, we'd make those both positive. And 55 divided by 5, we know is 11. So our slope on that one is 11. That's how they come up with the 11. All right, so now we go right into parallel and perpendicular. So we need to talk about what that means as far as parallel and perpendicular lines. I want to jump back into the PowerPoint. So I believe they have some slides that can help us with that. Let's get back. That slide just kind of goes over that standard form we already talked about. All right, we did that already. All right, parallel and perpendicular lines. Two lines that never intersect are what we call parallel lines. That means they do not cross. They kind of, easiest way to think of them as railroad tracks. Parallel lines, they will have the same slope. So the two slopes are going to be equal, okay? You could have two vertical lines, which means their slopes are undefined, but they can also be parallel. But that's what we're talking about with parallel lines. The ones that are a little bit more work are perpendicular lines. Perpendicular lines, they cross and they'll actually make 90-degree angles. So you think of like a tic-tac-toe kind of bar. And their slopes are what we call negative reciprocals, or opposite reciprocals of each other. They're products. That means when you multiply them together, you'll get -1, but that's not so much important. But these are what perpendicular lines look like. And you see as they cross, they form 90-degree angles in each of their corners. And we're going to do definitely some examples of these. Before we get into that, I really want to kind of show you. So again, parallel lines. They really are easy because if one slope is 3, the other slope would have to be 3. Their slopes would have to be completely equal. If one was 5, the other one would have to be 5 for them to be parallel lines. Just equal, their slopes are the same. Or what we call equal. They have to be exactly the same. One can't be positive and the other negative. If one's negative, the other one has to be negative in order for it to be a parallel lines. The ones that are a little trickier. Perpendicular lines. So let's look at some examples. So if one was, let's say, 2/3. The perpendicular slope, opposite reciprocal. So if one was positive 2/3, the opposite would be negative 2/3, and then reciprocal means you have to flip it. So it would look like that. These are perpendicular lines. If they are reciprocals, but they're not opposite signs, then they're nothing. Okay, so they not only have to be reciprocals, they have to be opposites. Let's say one slope, let's go with a negative value. If we had one slope of -3, what would be the perpendicular slope to that? Again, you got to remember that this is over 1, right? So we would have to flip it around first. All right, and then if this is negative, this one has to be positive. If this one was also negative, we don't have it. So opposite signs, one's positive, one's negative, and then reciprocals of each other. One more example. Let's say we have 4/5. What would the perpendicular slope to that be? Again, you have to flip it around. Okay, and one of them has to become, one's positive, the other one has to be negative. All right, so let's get into some examples of these. All right, so this problem, it gives you 2 points. -1, -5, and 0, 0. And the first thing it asks you is, what is the slope of the parallel lines? Well, if I want to find the slope of the parallel lines, first thing I would want to do is I got to find what is that slope. That's going to always be my first step. I got 2 points. So I use the slope formula, x, y, 1, 1, 2, 2. Do 0, take away a -5, over 0, take away a -1. So remember these double negatives, these are going to make this 5 over 1, or just 5. So if it's parallel to these 2 points, that means it has the same slope as these 2 points. So what is the slope of these 2 points? The slope would be 5. So the parallel slope would also be 5. That's the first thing we want to answer. The slope of the parallel line is 5. I think this is one of these 2-part. Okay. So first part asks, what is the parallel slope? The second part wants to know what would the perpendicular point be. So we know if the parallel point is 5, what would the perpendicular point to that be? Okay, again, you got to take the 5 over 1, and we have to do the opposite reciprocal. So opposite reciprocal means it's positive, so it's going to become negative. And then we're going to flip the 5 over 1 and make it 1 negative 1 over 5. We go back into our problem. Oops. And we said it would be -1 over 5. Check your answer, and you're good. So that's how you're going to do those. All right, let's look at this problem here. It's not really going to require me to write much down. These are both in slope-intercept form. You'll notice one slope is 9 over 8. The other one is -9 over 8. So their slopes are opposite. okay? But what are they not? They are not reciprocal. So basically they're asking you, are they the same? Are they parallel lines? Are these two slopes the same? 9/8 and negative 9/8? No. They're both 9/8, but one's positive, one's negative. So they're not parallel. The next question, are they perpendicular? So are they opposite reciprocals? Well, they are opposites because one's positive, one's negative, but they are not reciprocals, right? Because this, for them to be reciprocal, this would have to be 8/9. So what do we have here? We have nothing. We have neither. They are not the same and they are not opposite reciprocals. So they are neither. All right, and this is a good example. Let's get a similar question. We have two different lines, and if you notice on these two different lines, they're in different forms, okay? So that first one, x minus 3y equals -6, is in standard form. The second one, y equals 3x minus 6, is in slope-intercept form, okay? So we have two different ways to find the slopes on these. I'll tell you this first, this y equals 3x minus 6 is really the easy one because it's in slope-intercept form. We said slope-intercept form is y equals mx plus b, where m is our slope. So what's our slope on the first one? Our slope is going to be m equals 3. Sorry, and this is the second equation, this one right here. This is in standard form, so it's going to require a tiny bit more work. Again, the formula for a slope when a problem is in standard form is -a/b. And again, standard form is ax plus by equals c. So our a in this problem is 1, but we're doing -a. So in other words, we're going to have a -1. And we're going to divide it by b. In this case, our b is -3. But again, I got negative over a negative, so these would turn into a positive. So let's look at these two slopes. These are the two slopes we're comparing. First thing you ask yourself, are they the same? Are they both the same number? And the answer to that is no. So they're not parallel because this is 3, this is 1/3. So these are not parallel slopes, they're not the same. The next question, are they perpendicular? Are they opposite reciprocals? Okay, and one thing I want you to notice is, yes, they are reciprocals of each other. If I take 3/1 and I flip it, I get 1/3. But the problem is they're not opposite, right? You guys see how they're both positive values? So once again, they're not parallel and they're not perpendicular. The answer then is neither. So you come back, and again, we have a neither. They are not perpendicular, nor are they parallel. Get a similar question to this one. Again, we have two different equations, and I'm going to write them kind of a little bit differently. All right, so we want to determine, are these parallel or perpendicular lines? When I look at this first equation, I'm looking, is this in standard form or slope-intercept form? And it is not in either form. So I need to do something to these to get this in one of those two forms in order to find the slope. The easiest way to do that on these is to get the x and the y on the same side. So in other words, if I subtract 7y to both sides, I'm going to get 4x minus 7y equals 4. So now it is in my standard form that I wanted, the ax plus by equals c. Because once it's in that form, I can use this equation to find the slope. So I'm going to take the negative of the A. In other words, I'm going to do negative 4 over B. And in this case, it's B is negative 7. So I have negative over negative. That's going to give me 4 over 7. Both those negatives make this a positive. This one is already in standard form. It's already in AX plus BY form. So I can use that negative A over B. The A is already negative 20. So if I do the negative of negative 20, that's going to make this a positive 20. And B would be 35. So right off the bat, I would look at these and say, oh no, they're not the same. Problem is this is not reduced, right? Both of these numbers 5 can go into. So this ends up giving me 4 over 7. So again, you're looking at these two slopes, 4 over 7 and 4 over 7. Well, they're both the same. If they're both the same, what do we know? We know they are parallel lines. So the slope on that example, you would say they are parallel. All right, so that's kind of where we're at with 3.4. I know there's kind of a lot with 3.4. But that is the last section here for chapter 3. I also, like I said, on document sharing, you can find your chapter 3 review. So I will need you to get all of